First, let's look at the pthread's thread abstraction and the thread creation mechanism that corresponds to the mechanisms that were proposed by Birel. Birel proposed the thread abstraction and the fork and join mechanisms that work with that abstraction. To represent threads, pthread supports a pthread_t data type. That's the thread data type. Like the Birel thread data type, variables of this type will uniquely be identified with an identifier and will describe a thread, in this case a pthreads thread. They'll have an ID, execution state, any other information that's relevant to the thread. Most of this is not something that you will directly see as a developer. Instead, this is information that's used and maintained by the pthreads library. The equivalent to the fork that Birel proposes is a more intuitive call pthread create. It takes as arguments a start routine, that's the equivalent to proc in fork, as well as arguments, equivalent to the arguments in fork. It creates, as a result, and returns a new data structure that's of the type pthread type, and it's populated with all the relevant information so that this thread can start executing. It also takes as an input a variable of type pthread attribute type, and this is a data structure that you can use to specify certain things about the thread that the pthreads library will need to take into consideration when managing the thread. We'll look at this in more detail shortly. Pthread create also returns status information that indicates whether the creation was successful or a failure. Last, the alternative to join is pthread join. It takes two parameters, the thread structure, that's the thread that needs to be joined, as well as a status variable. The status variable will capture all of the relevant return information, as well as the results that are returned from the thread. The overall operation also returns a status that indicates whether the join was successful or it failed. As you can see, these operations are fairly analogous to the operations that were proposed by Birel. I would now like to talk in a little more detail about pthread attributes. As we previously saw, there is a pthread attribute type argument to the pthread create function. This argument gives us flexibility to specify certain features of the newly created thread. For instance, we can specify the stack size, scheduling policy, or priority of the new thread. We can set the scope of the new thread, whether it's system or process, like what we explained in the previous lesson, whether the thread should inherit attributes from the calling thread, whether it's joinable. Pthreads establishes some default values for all of these parameters, and if you pass null as an argument to the pthread create function, you will achieve that default behavior. There are several calls that support operations on pthread attributes. Pthread attribute init or destroy allow us to create and initialize the attribute data structure or to destroy it and free that data structure from memory. Pthread setGet allows us to either set the value of an attribute field or to read that value. One of these attributes requires particular attention, and that's joinable. To explain this, I will first need to explain some mechanisms that are supported by pthreads but were not considered by Birel. The mechanism not considered by Birel is detachable threads. In pthreads, the default behavior of thread creation is just like what Birel described. The threads are joinable. With joinable threads, the parent thread creates children threads and can join them at a later time. The parent thread should not terminate until the children threads have completed their execution and have been joined via the explicit join operation. If the parent thread exits early, the children threads can turn into zombies because they may have completed or died but not exited or have not been reaped properly. In pthreads, there is a possibility for the children threads to be detached from the parent. Once detached, these threads cannot be joined. If a parent exits, these children are free to continue their execution. This really makes the parent and the children equivalent to one another, with the exception that the parent threads have some additional information on the children that they have created. To detach threads, pthread provides a pthread detach operation that takes the thread data structure, the thread that needs to be detached, as an argument. Threads also can be created as detached threads using the attribute detached state. The value of this attribute first needs to be set to pthread create detached because otherwise the default behavior for pthreads is for threads to be created as joinable threads. So with detached threads, since the parent thread doesn't need to stick around to wait for the children threads to complete, it can simply exit using pthread exit. Here is an example of using pthread attributes. First, the pthread attribute data structure must be created and initialized. This will allocate the data structure with sufficient memory, and it will set its values to the default pthread parameters. We can also adjust the values of the attributes using calls like pthread attributes set detached state or set scope, or whichever other attributes we want to adjust. For instance, here we're setting the detached state to be pthread create detached, like what we described just a minute ago. And we're setting the scope, the scheduling scope of the threading system, to be the system scope. This means that the newly created thread will share resources equally with all other threads in the system. Once the attributes have been initialized and set to the desired values, the resulting data structure is passed to the call pthread create.